Mariner 9. This NASA probe was the first spacecraft in human history to orbit another planet. Arriving at Mars in November 1971 during a raging global dust storm, it had to patiently wait for the dust to clear. When it did, Mariner 9 revealed a stunning, completely new Mars. It systematically mapped 100% of the planet's surface, discovering the colossal Valles Marineris canyon system, the giant Tharsis volcanoes, and the channels of ancient dried-up rivers, forever changing our view of Mars from a dead, cratered ball to a dynamic geological world. Mars 2 and 3. Arriving just weeks after Mariner 9, these twin Soviet spacecraft were the first from their nation to successfully enter orbit around Mars. While their primary fame comes from their lander components, one of which crashed and the other of which made the first soft landing on Mars, but transmitted for only about 14.5 seconds, the orbiters themselves were long-term successes. For many months, they conducted a wide range of scientific experiments, studying the composition of the atmosphere, mapping surface temperatures, and providing the Soviet Union with its first long-duration presence at the Red Planet. Mars 5. Part of a later Soviet assault on Mars in 1974, Mars 5 was a successful orbiter. It entered orbit and operated for several weeks, returning valuable photographs and data that were used to help guide its companion landers, Mars 6 and 7. Its mission, however, was cut short after 22 orbits, when its transmitter failed, ending its observations prematurely. Viking 1 and 2. The orbiters from NASA's legendary Viking program were powerful scientific platforms in their own right. Arriving in 1976, their first job was to conduct detailed reconnaissance to certify the safety of the landing sites for their lander companions. After successfully deploying the landers, the orbiters embarked on a multi-year mapping campaign. They provided the first detailed global photographic maps of Mars and served as essential communications relays, sending much of the landers' data and images back to Earth, while the landers could also communicate directly with Earth. Phobos 2, the last planetary mission of the Soviet Union, Phobos 2 successfully reached Mars and entered orbit in January 1989. For several months, it returned valuable data on the Martian atmosphere and magnetosphere as it prepared for its primary goal, a close encounter with the moon Phobos. Tragically, just as it began maneuvering for its close encounter with Phobos, contact was permanently lost. Archival sources usually describe the cause more cautiously as either an onboard computer failure or a radio transmitter failure. It was a partial success that ended just moments before its main event. MGS. This was NASA's triumphant comeback to Mars after a 20-year hiatus. Arriving in 1997, MGS was a mapping powerhouse. For nearly a decade, its high-resolution camera and laser altimeter created the first precise 3D maps of the entire planet. It revealed ancient riverbeds, deltas, and fresh-looking gullies that suggested water might have flowed on Mars in the very recent past, revolutionizing our understanding of Martian water history. 2001 Mars Odyssey, the longevity champion of Mars. Arriving in 2001, Mars Odyssey is still operational today. Its primary scientific discovery was monumental. Using its gamma-ray spectrometer, it mapped the distribution of elements on the surface and found vast deposits of subsurface water ice across the planet. Its second, equally important role has been to serve as the primary communications relay for every NASA rover on the surface, from Spirit and Opportunity to Curiosity and Perseverance. Mars Express, Europe's first and highly successful mission to another planet. Arriving in 2003, the Mars Express orbiter has been studying the planet's atmosphere and geology for more than 2 decades. Its MARSIS radar instrument was a breakthrough. probing beneath the surface to confirm that the polar ice caps were indeed made of thick layers of water ice, and even detecting what could be a subsurface lake of salty water. MRO, NASA's high-resolution eye in the sky. Arriving in 2006, MRO's camera, HiRISE, is the most powerful ever sent to another planet, capable of resolving features on the surface the size of a dinner table. It acts as a reconnaissance scout, providing the ultra-detailed images needed to select safe and scientifically interesting landing sites for all rovers and landers. It has also revealed a dynamic world, capturing images of active avalanches, dust storms, and mysterious seasonal dark streaks. Mangalyaan, India's first interplanetary mission and a stunning technological triumph. Arriving in 2014, Mangalyaan made India the fourth entity to successfully reach Mars orbit, and the first nation to do so on its very first attempt. Developed on a remarkably small budget, it served primarily as a technology demonstrator, while its small suite of instruments studied the Martian atmosphere, making it a massive source of national pride and inspiration. MAVEN, NASA's atmospheric specialist. The Mars Atmosphere and Volatile Evolution Orbiter arrived in 2014 with one primary goal: to understand how and why Mars lost its once thick atmosphere and abundant water. By dipping into the upper atmosphere, its instruments directly sample the atmospheric gases and study how they are being stripped away by the solar wind, providing definitive answers about how Mars transformed from a potentially habitable world into a cold desert. TGO, a joint European-Russian mission designed to be a highly sensitive nose in orbit. The TGO's primary mission is to create a detailed inventory of trace gases in the Martian atmosphere, especially methane. Because methane can be produced by either geological activity or biological processes, its presence is a tantalizing mystery. TGO's extreme sensitivity allows it to map the gas in tiny concentrations to try and pinpoint its source. HOPE, the Arab world's first interplanetary mission. Arriving in 2021, the HOPE orbiter is the first true weather satellite for another planet. It was specifically designed to fly in a unique high-altitude orbit that allows it to provide a global, 24/7 picture of the Martian atmosphere across different times of day and through all of its seasons. Its mission is to study the connections between the lower and upper atmosphere, providing a complete and holistic view of the Martian climate. Tianwen 1. China's first Mars mission was a stunningly ambitious, all-in-one success. The Tianwen 1 orbiter arrived in 2021 and began scientific observations in parking orbit while also reconnoitering the landing site for rover deployment. It first had to serve as a reconnaissance scout and then as the communications relay for the successful deployment of its Zhurong rover to the surface. The orbiter then continued its broader scientific mission using 7 instruments, including remote sensing cameras, a subsurface exploration radar, a mineralogy spectrometer, and particle and magnetic field instruments to map and study Mars while also supporting relay operations for Zhurong. Thanks for watching. What do you want me to cover next? Let me know in the comments. Also, please remember to like and subscribe if you enjoyed this video.